So the next thing after we pick the site is we have to go out and take samples using sediment cores.
We brought some props here too. We have the props.
And so what we did was take a 2.5 centimeter or maybe 2.5 inch polycarbonate tube, and you stuck it into the sediment. And we did a similar thing to when you put a straw in water and put your thumb on top and pull it out. It keeps the water in. And we did a similar thing, but with a stopper, and put that on top, pulled it out, and you got an intact sediment core. So it's the same exact sediment that goes down with depth. So if you're looking at the top part of your core in the lab, you know that's the part that's right even with the water. And as you go down, it's the same as it is in the environment. And so that's what we did. We brought those back to the lab, and then we also took some water samples and did some visual inspections of the sediment. So the two things that we did with the cores after we brought them back to our lab were two different methods of analysis. And the goal was to figure out, again, where these bacterial populations were living, and to figure out where the sulfate-reducing bacteria live, so we know if they're creating methylmercury. So first we used some little electrodes to go down and measure the water in the pores of the sediment to see where the sulfate is being changed to sulfide. And so that's our little electrodes that we stuck into the sediment. And that's kind of a non-destructive way of figuring out what's going on, so you don't have to cut up the sediment or anything like that and introduce new things into the sediment.
These aren't real important too, so if they break, they're not the end of the world.
What were these measuring again?
They measure iron, reduced iron, sulfide. They can also measure oxygen and manganese.
Just in real time.
Yep, exactly, in real time within the sediment, so we know exactly where those or they can give us clues where the populations are occurring.
Now your core samples, I know, like ice cores, cut up. How did you work with the core once it's in the tube? Do you push it out, or do you cut the tubes?
Yeah, that's exact. So the next thing that we did.
So the first method was kind of non-destructive. We stuck these electrodes in, and you can imagine they just sort of went in between the sediment particles, and we pulled them back out, and the rest of the core is pretty much intact. We didn't really disturb it very much. So the principle here kind of is that we use the non-destructive method first to analyze a few things, and then
and then the next method that we used was, so what you did is put that core tube on top of kind of a piston or something, and you push down on the core tube, and then the sediment comes out, and you can slice off, let's say, 1 centimeter slices or 1 inch slices, put them in a jar, and then analyze them later. And so that's the kind of more destructive thing that analysis that we did. And you can analyze things like methylmercury, organic matter, and various parameters.